Okay, chemistry 1411. This is practice exam 5. First question, alkenes have the general formula. Well, if we draw the bond line structure of an alkene, like let's say we draw propene, or if we draw 1-butene, or if we draw, 2-butene, either way, they all have the same general formula, which is CnH2n. Okay, CnH2n. If you look at the molecular formula here, I have C3H6. Here I have C4H8, and here I also have C4H8. And all three of these molecules are alkenes. If we just zoom in on one of them and pencil in all the hydrogens, I have 2 hydrogens on this carbon. I have 1 here in my bond line structure. I have 2 here, and then I have 3 on this methyl group over here. So the general formula for an alkene is CnH2n. Again, all of these alkenes have the same general formula. What about a cycloalkane? So it says cycloalkanes have the general formula. If I draw a cycloalkane, like whether it's cyclobutane or cyclopentane or cyclohexane, you can see that if I have 4 carbons, I have C4H8. If I have C5, I have H10. And if I have C6, I have H12, right? The reason why is because each one of the CH2s has, of course, 2 hydrogens attached to it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll just do the cyclopentane as an example. So all of these cycloalkanes have the same generic formula, which is also CnH2n, which is B. So you see that whether you have an alkene or a cycloalkane, the double bond or a ring counts as 1 unit of unsaturation and leads to the same general formula in both cases. All right, number 3, it says the formula CH3, carbon with a triple bond to another carbon, and then another CH3. We have a functional group in here, don't we? We have a triple bond between 2 carbons, and we call that an alkyne, A. So the generic structure of an alkyne is when we have an R group, and then we have another carbon attached to another carbon by a triple bond, and then another R group. So this is an alkyne. This molecule here is called 2-butane. Question number 4, how many structural isomers are there of C4H10? That means, or is asking, how many different ways can I connect the 4 carbons and the 10 hydrogens? Well, one way is to connect them all like this in butane, right? Which is the same thing as CH3, CH2, CH2, CH3. There is, in fact, only one other way for me to connect 4 carbons and 10 hydrogens together, and that is to put them like this, okay? We call that molecule isobutane, or you could call it 2-methyl-propane, and that is where we have a methyl group, a CH3, attached to a CH, or a methine, and then 2 more methyl groups like that. So this molecule is called butane, and this molecule is called isobutane, or the IUPAC name would be 2-methyl-propane. Question number 5. The 2 molecules represented below are examples of, well, if you take a look at the first one, it's a ketone, right? This molecule is a ketone, and this molecule is an aldehyde, right? Because when we have a ketone, we have an R group, we have a carbonyl, and then we have another R group, which can be the same or different. When we have an aldehyde, we have an R group with a carbonyl and another hydrogen atom like this. However, if you look at the molecular formulas of both of these compounds, both are C4H8O. So they have the same molecular formula, they're just connected differently. So the answer is they're not alcohols, they're not unsaturated hydrocarbons, that would be an alkene or an alkyne. They're not isotopes, they're not carboxylic acids. What are they? They are isomers of each other. They're made from the same numbers of atoms, but they have a different connectivity, or they're connected in a different way. Question number 6, what is the name of this big old molecule here? So we have a linear hydrocarbon chain, and we can count the number of carbons in there. let's see, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons, right? If we wanted to draw a bond line structure, we would draw 1, 2, 3, 4, 5, 6, 7, 8. The name of that molecule is octane. And so the answer is B. You need to know that when you go from 1 to 10 carbons, it follows the order methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Okay, so not only do you have to know what octane is, but you also have to know what all of these other things mean. Butane, which has 4 carbons, nonane, which has 9 carbons, heptane, which has 7 carbons, and hexane, which has 6 carbons. Next question deals with nomenclature, naming a compound. So what do we do first when we have an alkane, right? This compound is an alkane. There is no double bond, there is no triple bond, there's no alcohol, there's no oxygen. So the first thing we want to do is find the longest chain. Now I've gone ahead and done some of the work here already, and one of the longest chains is if we go 1, 2, 3, 4, 5, 6, 7, like that. We have 7 carbons in a row, which means that this is some kind of heptane. All right, some kind of heptane. Now, if you had stopped at carbon 4, and I'll just move down here, if you had done this 4, 5, 6, 7, you still end up with a kind of heptane. But even if you had gone this way or this way, you still end up with the exact same name for the compound. So it doesn't matter which way you go. I'll just leave it the way that I have it now. Now, we've got 2 substituents on this heptane chain, don't we? The 7 carbon chain. We have a substituent at carbon 3, which is a methyl. So this is a 3-methyl or 3-methyl. We also have a substituent over here. This is a 4-propyl, right? This is a propyl chain, 3 carbons in a row. So now we're going to put the entire name together. Now, the parent is heptane, so that comes last. But when it comes to the propyl and the methyl, I'm going to list them in alphabetical order. M comes before P in the alphabet, and so the molecule will be 3-methyl, 4-propyl heptane, which is E. Let's move on to question 8, which deals with functional groups. Again, it asks you which option represents dimethyl ether. Well, the first thing you need to know is what is an ether, right? An ether is when you have an R group attached to an oxygen and then another R group attached to it. It can be the same or different. So if I have a dimethyl ether, we know that a methyl group is a CH3 group attached to something. And so if I have my oxygen and I have a methyl group on one side, a methyl group on one side, and if I have a methyl group on the opposite side, that gives me dimethyl, right? Di meaning 2. That's 2 methyl groups on my ether. If we take a look at the first answer, this is an alcohol. The next one is an ether, but this has an ethyl group on one side and a methyl group on the other, so that's incorrect. The next one is also an alcohol. If you go down to E, this is the condensed structure of a ketone. And so the answer is D, which shows the exact same molecule that I have drawn in the yellow box. Here they've just drawn a more condensed structure. They've left out these 2 sigma bonds here, but it means the exact same thing. All right, question number 9 deals with ketones. Which one of the following functional groups is found in ketones? Well, you need to know a functional group. You need to know all the functional groups that we covered in class. And when we have an R group attached to a carbonyl, which is attached to another R group, which again could be the same or different, this is a ketone. And so the correct answer is C, which is going to be answer A. If we take a look at the other functional groups that we have in here, A, this is an alcohol, and we have an R group attached to a hydroxyl, or an OH, which I call it sometimes in general chemistry too. The next one is an ether, and we looked at an ether just a few moments ago. The next one, D, this is a carboxylic acid. Oops, carboxylic acid. Oops, didn't mean to do that. Acid. And the last one is an ester. Okay, so you need to be fully cognizant of all these different R groups, but of course, C is the ketone. All right, which one of these choices is the correct formula of an aldehyde? Well, here it's a matter of knowing the condensed form of an aldehyde. And I went over this with you in class. I said if we have an aldehyde, which is a carbonyl attached to an R group and a hydrogen, I said that the condensed form of this is to write RCHO. And this represents the exact same thing as what's shown in this blue circle on the left-hand side. And so if you look at B, you can see that B is an ether, so that's incorrect. C is an alkyne, also incorrect. D is a carboxylic acid. Carboxylic acid. Right, if I have a carboxylic acid, I'll just draw one down here quickly. We have our carbonyl, then a hydroxyl. The condensed form of a carboxylic acid can be RCOOH, or you can even shorten it to RCO2H. Either one is fine. And the last one is a ketone. So the last one is a ketone. And again, I showed you that for a ketone, we can have this, or you can also write it as RCO, R like that. That's a condensed form of the ketone. And so the correct answer is A. This is called acetaldehyde. All right. Let's move on to question number 11. It says the expected product of the addition of HCl to this molecule, this alkene, see that we have an alkene here, is something. Well, let's draw out the reaction. We have this molecule. So we have our double bond here. The name of this molecule would be 1, 2, 3, 4. It would be 1-butene. So 1-butene. And when we treat that with HCl, we know the rule that the rich get richer, right? Rich get richer. Well, this carbon is richer in hydrogens than this one. The one that I have in the red circle now has 2 hydrogens, and the one that's in the blue circle only has 1 hydrogen. Therefore, the red one is going to take on this proton from the HCl, and the other carbon in blue is going to take the chlorine atom. So what am I going to get? Let's write it out. We're going to have a CH3 and a CH2, a CH with a chlorine attached to it, and then a CH3. If I want to name that molecule, it would be 2-chlorobutane. But then if I look at the possible answers, 2-chlorobutane is shown here in B. 2-chlorobutane. There we go. The reaction of an alcohol and a carboxylic acid produces what? When we take an alcohol and we treat it with a carboxylic acid, which I'm just going to draw like this. So this is a carboxylic acid. What do we get? When we treat that with a little bit of acid, I'm going to represent that by H+, and that's not really here nor there for general chemistry 2, but this is just a tiny bit of acid. It means a catalytic amount of acid, but again, I'm not really going to test you on that. You just need to know that when you combine an alcohol and a carboxylic acid, you end up losing H2O, right? You end up producing water as a side product, and then you also produce an organic molecule. Let's draw what you've got. You've got an R and an O group, then you have left over the carbonyl and the R prime, like that. What functional group is in this compound? This is an ester. Okay, this is one of the most important reactions that you'll learn in organic chemistry. If you take chemistry 1211, let's say, at UCCS, it's a very important reaction in that class. So the formation of an ester from an alcohol and a carboxylic acid. Question number 13, the reaction of chlorine with methane to produce methyl chloride is an example of what? Well, if we draw the Lewis structure of methane, CH4, and we treat that with Cl2, right? We're not going to be doing anything with a double bond, okay, like an alkene, and we looked at reactions between a halogen and an alkene. What are we doing here? We're going to be replacing one of the hydrogens with one of the chlorines. All right, let's take a look. We're going to have a product where we end up replacing one hydrogen with one of the chlorines. then what's going to be left over? I'm going to have the hydrogen that I lost plus one more chlorine atom. So that means that I'll have this product, methyl chloride, plus HCl, hydrochloric acid, or hydrogen chloride. So this is my methyl chloride. Now, what kind of reaction is this? I've got substitution, addition, polymerization, reduction, and ester hydrolysis. This is a substitution reaction because I'm substituting this hydrogen for this chlorine, right? This is substitution, right? I'm just substituting one atom for the other, A. Question 14, amines are organic acids. You can see that possible answers involve organic acids and organic bases. Well, the first thing is that amines are not acids. They are, in fact, organic bases. So that means that a possible answer could be C or D. It says organic bases react with water to produce ammonia, or organic bases that react with acids to form ammonium salts. The correct choice is D. Let me show you why. If we take an amine, okay, and I'm just going to draw an amine, a generic amine like this. I have an R group like that, okay? If I take that amine and I treat it with HCl, right? The amine is going to behave as a base, and the HCl is, of course, going to behave as an acid. What's an acid do? It donates protons, okay? So this nitrogen is going to end up taking that hydrogen atom and the chlorine is going to take the pair of electrons that's left over to form chloride. Even if you don't follow me on those arrows that I drew to kind of help us walk through it, what would you be left over with? You end up with a nitrogen that now has 3 hydrogens and 1 R group bound to it, and chlorine that instead of having just 3 lone pairs, now it's got 4 lone pairs. So that makes chloride. What's the formal charge in this nitrogen? Nitrogen has 5 valence electrons, subtract 4 bonds and 0 lone pairs. That means it's got a charge of +1. So I end up with an ammonium ion, right? And the chloride as the anion. So this is an ammonium salt. It's not table salt, but it is an ammonium salt. So put here in ammonium salt. Now I just want to address answer C here very quickly. I don't have a lot of space to do it, but it says amines react with water to produce ammonia. That's not true. An amine can react with water. Let's say you have ammonia, right, which is the simplest possible. I mean, if you put that in water, what do you get? Right, go back to the acids-bases equilibria. The amine acts as a base, takes a proton to form ammonium, but what do you get? You end up with hydroxide, right? So it doesn't produce ammonia, it produces hydroxide, and that's chemistry that you must know as a General Chemistry 2 student. Question 15, more nomenclature. Just name the following compound. This is an alkane. And alkane. What's the first thing we're going to do? We're going to find the longest carbon chain. You could pick those 4 carbons. You could pick those 4 carbons. You could pick those 4 carbons. Either way, you're going to end up with the exact same answer. Let's pick these 4. It doesn't matter if we put our number 1 here or if our number 1 here, we're going to end up with the same answer too. So I'll just number it like this: 1, 2, 3, 4. So our parent is butane, so it must be one of these answers here. It can't be A, B, or C. And then we have 2 methyl groups. We have a methyl group at carbon 2 and a methyl group at carbon 3. So this is 2,3-dimethyl butane. Question 16, which one of the following is an aromatic compound? Well, we talked about aromatic compounds, and we said that an aromatic compound like benzene has a structure like this, okay? And I'm just going to draw the bond line formula. You know that there's a carbon at each one of these vertexes. Each one is attached to 1 hydrogen. I'll erase that just to make it a little simpler, but you know that the formula is C6H6. Well, if I look at all of the possible answers, the only ones that have 6 carbons are B and C. So this is the only possibility for aromatic compounds. But an aromatic compound has the generic formula of CnHn, like this. We have C6H6. Now, what if I replaced one of those hydrogens with a bromine? Could I do that? Yeah, because bromine can form one bond only and have 3 lone pairs on it. Right, so C6H12, that would be like a cyclohexane, right? If I had this, C6H12, if each one of these carbons has 2 hydrogens attached to it, that is not aromatic. That is just a cycloalkane. In order for the compound to be aromatic, you have to have double and single bonds alternating, okay? So that means really the only possibility is going to be C6H4Br2. Let me show you how you get that. Again, I told you that you have 1, 2, 3, 4. Oops, I'm running out of space here. 4, 5, 6 hydrogens. What if you replace 2 of those with bromines? Look, if I take this molecule, and let's replace these 2 hydrogens with bromines, for example. It's still an aromatic compound, isn't it? But now my formula is C6H4Br2. So the answer is C. Question 17. Which of these is the systematic name for the compound represented below? Here we have an alkene, because we have a double bond right here. So we have an alkene of some sort. You could even look at the answers to make sure that they all have ene in the end, right? We have ene for A, C, and E. That means that we can eliminate B and D right away because they end in ane. Those are alkanes, and this is an alkene. What's the rule for alkenes? Is that we want to number them so that we give the double bond the lowest possible number. 1, 2, 3, 4, 5. The lowest possible number in the longest possible chain. If I just look at the chain that I have highlighted in yellow, this would be called 1-pentene, right? Because I have the double bond on the first carbon. So this is some kind of 1-pentene, and I only have one substituent. It's a methyl group at carbon 3, 3-methyl. So if I put that all together, I get 3-methyl 1-pentene. Question number 18, which structure is the correct one for 2,3,3-trimethylpentane? There's a couple of ways you could do this. I mean, you could just go ahead and name all of them. You know, just take the time. There's 4 molecules. Just give a name to every single one. That works. Whichever one has that name is going to be the right one. What I like to do with these kind of problems is I draw the bond line structure of the molecule. Okay, I've got a pentane, 1, 2, 3, 4, 5 carbons like that. I've got a methyl group on carbon 2, right? Again, this is 1, 2, 3, 4, 5. And I've got 2 carbons or 2 methyl groups on carbon number 3 like that. Could anybody tell me which one of these is a representation, what I have drawn as a bond line structure? And it's not a trick. Yeah, exactly. Thanks, Brogan. The answer is A, right? You can see that we have in A, we have 1, 2, 1, 2. Sorry, this is, it's actually not correctly. No, sorry, it's fine. 1, 2, 3, 4, 5. Sorry, I was having a lapse of judgment there for a second. Anyhow, so we have methyl groups at carbon 2, and we have 2 at carbon 3, so it would be 2, 3, 3 trimethylpentane, right? Remember that tri in chemistry represents 3 of something, so 3 methyl groups. All right, there we go. Question number 19 and 20 are true and false questions. You get a 50-50 chance on these, but you don't want to take your chances, do you? You want to get the right answer. So question 19 says, the oxidation product of 1-propanol with the dichromate ion as the oxidizing agent is acetone. Well, acetone is the same thing as propanone, which is this molecule. Okay, so if let me just move my acetone molecule out of the way first. Why don't I put it up here just to get it out of my way? Well, if I take one propanol. So 1, 2, 3. And on the first carbon, 1, 2, 3, if I put the alcohol over here, that's 1 propanol. If I oxidize it, and it tells me it's undergoing an oxidation with a primary, with dichromate, I'm just going to put O. If you want to put, Cr2O7 2 minus, it's just chromium 6 that's in the dichromate ion. It's a really powerful oxidizing agent. What would you end up with? You end up oxidizing it to an aldehyde. Okay, an aldehyde is not a ketone, and even if you weren't sure about what acetone is, since it ends in -one, you know it's a ketone. But as I told you, that when you have a primary alcohol like 1-propanol, you end up producing an aldehyde. And so the answer here is false. Question number 20, true or false? The reaction of hydrogen chloride gas with propene will yield 1-chloropropane as the main product. If I take propene, which would be this molecule, propene, and I treat that with hydrogen chloride gas, HCl, what am I going to employ here? I'm going to apply the old, fix those one pairs. I'm going to employ, the rich get richer. Since this carbon has 2 hydrogens, and this carbon only has 1 hydrogen, the carbon with the 2 hydrogens is going to take the other hydrogen, and the other carbon is going to take the chlorine atom. So let's draw what we would get from that. We have 3 carbons in a row, and now we have a chlorine atom here. If I number the longest chain, 1, 2, 3, now I have 2 chloropropane, 2 chloropropane. And it's not 1 propane, so this is also false. All right. Let's move on to question 21. This is where we get back into, get into nuclear chemistry. It says beta particles are identical to, and this is something that we talked about even in General Chemistry 1 when we talked about Rutherford's gold foil experiment. We said that an alpha particle is a helium nucleus. A helium nucleus, right? A beta part. Sorry, did I say beta particles? Sorry. Question 21 says beta particles are identical to. So a beta particle is a fast-moving electron. So we'll put here a fast-moving electron. All right. So we represent the beta particle as having no mass and having a -1 effect on the nucleus. And so we have a fast-moving electron, and so it is essentially an electron. Question 22 says identify the number of protons, neutrons, and nucleons, which is the sum of protons and neutrons in that order for this isotope. This is barium 137. I'm going to rewrite it since it came out so small here. So we have 137. Barium has an atomic number of 56. Well, the 56 represents the number of protons. The mass number represents the sum of protons and neutrons. So that means the number of neutrons is going to be equal to 137 subtract 56, which equals 81. So now I've got 56, I've got 81, and then the sum of the number of nucleons is the neutrons plus protons, which is 137. And that must be one of the answers. All right. So that is answer D. Question 23 is something that we went over in class. It says, which of the following represents a rule for balancing a nuclear equation? We spent quite a bit of time balancing some nuclear equations, and I also assigned some questions from the textbook that deal with balancing nuclear equations. The total number of protons plus neutrons in the products plus reactants must be the same. This is absolutely true. 100% true. Number 2, the total number of each type of element in the products and reactants must be the same. Well, that's not true, because the whole point behind nuclear chemistry is changing the identity of elements, which is something that we didn't do in all the other chapters, but that's what we can do in nuclear chemistry. Bullet point 3, it says the total number of nuclear charges in the products and reactants must stay the same. Yes, we have to balance. Yes, we have to balance our charges. That is correct. And then number 4, the total number of each type of elementary particle in the products and reactants must be the same. Absolutely not. Right? If we have a parent nuclide, it can yield maybe a beta particle and a daughter nucleus. So no, they're not going to be the same on each side. So there we go. So the answer is number 1 and number 3. Is that one of the answers? Yep, there we go. 1 and 3. So again, you need to know how to balance nuclear equations in order to complete exam number 5. Question 24, as a result of alpha emission, the product nucleus is, well, we have some answers here. Let's write down an example of a potential or a possible alpha emission. So we have example here. I chose if you had, let's say, radium-226, so radium-226, okay? If that was to yield an alpha particle, which I'm going to represent as just a helium nucleus like this, plus radon-222, what happened to the product nucleus? We went from an atomic number of 88 to an atomic number of 86. And so what's happening here is that the atomic number is 2 atomic numbers, or the atomic number of the product is 2 atomic numbers lower than that of the original element A. Question 25, just balancing a nuclear reaction. It says when atoms of aluminum-27 are bombarded with alpha particles, there's an alpha particle, you get a neutron and something formed. Well, if we look at this question carefully, you see that the sum of the mass numbers of the alpha particle in the aluminum-27 are 31. So we have 31 over here, okay? And then we have 1 on the other side. So 1 plus what gives me 31? And the answer is 30. So we have a mass number of 30 for our product. Then if we look at the atomic numbers, here we have 2 plus 13, which gives me 15. 0 plus what gives me 15? I have 15 over here. Here I have 0 plus 15. I go over to my periodic table, which is on the floor, and I look at element number 15, which is phosphorus. And so there's the answer. It must be phosphorus 30, which is E. Same type of question here in 26, more balancing a nuclear equation. So we have lithium-6 plus a neutron gives you something plus an alpha particle. Look, we're going to employ the exact same rationale. Here we have 6 plus 1. That gives me a total of 7 is equal to something plus 4. That something must be 3. Okay. If I look at the mass numbers, or sorry, the atomic numbers rather, I have 3 plus 0, so that gives me 3. And then I have 2. 2 plus something gives me 3. So that something must be 1. If I go over to the periodic table and I look up element number 1, it's hydrogen. So it's hydrogen 3 or a tritium. Question 27, we have a beautiful decay series here for us. Notice the axes. On the y-axis here, if you will, I have the number of neutrons. So this is the total number of neutrons. On the x-axis here, on the x-axis here, I have the number of protons, okay? And we know that when we have an elemental symbol, that we have our mass number and we have our atomic number, right? Our atomic number represents the number of protons. Our mass number represents the number of neutrons plus protons. So let's see if we can figure out what we get. Well, it's telling us that what is the product Z? Well, if we look at Z, which is right here, you see that we have 126 neutrons and 84 protons, right? I just drew a line over here to 126 neutrons and 84 protons. Well, if it's got 84 protons, I go over to my periodic table and I look up element number 84. And it's going to be polonium. That's an atomic number of 84. For my mass number, A, I just tally up 126 plus 84. And when I tally up 126 and 84, I get 210. And so it's going to be polonium 210, which is A. Number 28, more balancing of a nuclear reaction. However, in this case, we have to write out the reaction ourselves. It says you have sulfur 35. It undergoes decay by beta emission. And what's the decay product? Well, first we're starting it with sulfur 35. So we have sulfur 35. I go over to my periodic table. Sulfur is element number 16. If it's undergoing beta decay, I'm going to lose a beta particle, right? This is the whole concept behind beta decay, is the loss of a beta particle. Now I just need to balance it out. If I have a total of 35 for my mass number, and if I have 0 as the mass of my beta particle, that tells me that my product is going to have a mass number of 35. And for my atomic number, here I have 16, and over here I have -1. -1 plus what gives me 16? The answer is 17. I go over to my periodic table. I see element number 17 is chlorine. And so the answer is chlorine 35. There we go. D. Question 29, another decay series. The exact same rationale that we looked at in question or a couple of questions ago. We have, it's asking you, what is the symbol for the product labeled as Y? So I just noticed that in my answer, what did I put here? Oh, I chose Z in my answer, so I'm gonna have to double check that. But anyhow, it's asking you about Y. So you're not asked about Z, so I'll cross that one out and I'll fix my mistake right now. Well, we can see that for Y, we have Y. The total number of protons is 84, and the total number of neutrons is 126. So for my mass number, I have protons plus neutrons, so that's 84 plus 126. Okay, I think we saw this just a couple of seconds ago, right? And we get 210. So 210, I go over to my periodic table, I look up element number 84, and it's polonium. So polonium 210. So the answer is E, polonium 210. All right, let's keep moving. Question number 30 of balanced nuclear equation representing the beta emission of iodine 131 is which of the following? So we have beta emission of iodine 131. So what is that going to look like? We're going to start out with our iodine 131. I go over to the periodic table. I look at the group 7A, the halogens. Iodine is element number 53. It's going to lose a beta particle, which we can represent like this. Of course, you can also represent it like that. Either way is fine. Well, what is the other product that we're going to have? We have 131 for our mass number. We have 0 for the mass of the beta particle. So we have 131 for the mass number of our product. Here we have 53 as our atomic number. -1 plus what gives me 53? It's element number 54. I go over to my periodic table again. Element number 54 is xenon. And so here is the equation. I have to look to see which one of these is correct. And the answer is C. We have our iodine 131 producing xenon 131 and the beta particle.